All right, welcome to This Explainer. Today, we're going on an absolutely incredible journey to demystify some of the greatest mysteries of the universe. We're talking everything from Albert Einstein's revolutionary theories that completely upended our understanding of physics, all the way to the bizarre, mind-bending realities of time travel and black holes. If you've ever looked up at the night sky and felt a sense of overwhelming wonder, well, you are in the exact right place. We're going to unpack the very fabric of our reality and visualize concepts that might just change the way you think about literally everything around you. Let's dive in. So right now, as you're watching this, time is moving forward. It's something every single one of us experiences every second of every day, right? We measure it meticulously with calendars, ticking clocks, and these ultra-precise atomic clocks. But let's just ground ourselves in the present moment for a second and ask a seemingly simple question. What exactly is it? Like, could time ever stop? Could it slow down? Or maybe even move backward? Surprisingly, despite how strictly our daily lives are governed by it, scientists actually still wrestle with the fundamental nature of time. That brings us to Section 1, the illusion of everyday reality.
To kick things off, we need a working definition. Time is basically the continuous progression from the past through the present and into the future. It's the very mechanism that allows for movement, for growth, and for that fundamental rule of cause and effect. We measure it constantly. But think about this. If you could somehow hit a cosmic pause button on time itself, every single atom, every human heartbeat, and every massive planet in the universe would just completely freeze. Nothing could happen. Zero. That is how foundational time is. It's often called the fourth dimension, working perfectly in tandem with our physical world.
Now here's where it gets kind of crazy. Space isn't just some empty void holding things. Because light actually takes time to travel, space itself acts as a giant time machine. For instance, it takes light over 8 minutes to travel from our sun to Earth. That means you never actually see the sun exactly as it is right now. You're seeing it as it was 8 minutes ago. So when astronomers use telescopes to observe galaxies millions of light years away, they are literally seeing those galaxies as they existed millions of years in the past.
Let's move right into Section 2, the fabric of space-time. So you literally can't look through space without also looking through time. And this realization brings us to one of the most famous scientists in history and a massive paradigm shift that happened back in 1915, when Albert Einstein completely changed the game. His crucial point was that time is actually the fourth dimension, and it works together with the 3 dimensions of space, up, down, left, right, forward, backward, to create an interwoven 4-dimensional fabric. Einstein called this space-time. Instead of thinking of space as an empty room and time as a clock on the wall, he proved they're woven together into a single, flexible sheet that dictates how the entire universe behaves. Okay, so to easily picture how gravity works in this framework without getting bogged down in complex math, just imagine this. Picture a stretched out rubber sheet. That's our space-time. Now, place a heavy bowling ball right in the middle. Obviously, the sheet naturally sags and bends under the weight, right? Finally, if you roll a marble nearby, it doesn't move in a straight line anymore. It curves toward the bowling ball. Massive objects like our sun bend the fabric of space-time just like that bowling ball, causing smaller objects like Earth to follow those invisible curves. And that curving, that is exactly what we feel as gravity. All right, moving on to Section 3, the bizarre rules of time. Let's push these rules of physics to their absolute extremes, shall we? Because if gravity is just the bending of space and time, it means that time itself can be bent, stretched, and warped. And this leads us to one of Einstein's absolute strangest, most mind-bending discoveries, time dilation. This is the phenomenon where time actually passes slower for an object the faster it moves or the closer it gets to a source of immense gravity. Imagine you had a set of identical twins. If one stayed here on Earth and the other traveled in a spacecraft at nearly the speed of light, their experiences of time would physically differ. The traveling twin would return having aged only a few years, while decades would have passed for the twin back home. Now I know exactly what you're thinking. Come on, that sounds entirely like science fiction. But I promise you, it is absolute scientific fact. Scientists measure this with incredibly precise atomic clocks all the time. In fact, it affects your life every single day. The GPS satellites orbiting our planet are moving really fast, and they're further away from Earth's gravity. Because of this, they experience time slightly differently than we do on the ground. Their internal clocks literally have to mathematically correct for this time dilation constantly. If they didn't do that, the GPS navigation on your phone would fail and become hopelessly inaccurate within mere hours. And gravity's effect on time gets even wilder than that. Think about black holes. Those regions in space where gravity is so incredibly powerful that not even light can escape its pull. If you stood safely near the edge of an enormous black hole where gravity is bordering on infinite, time would slow down for you so drastically that just 1 hour of your time could equal several years for everyone else back on Earth. This exact phenomenon was beautifully visualized in the movie Interstellar, and the underlying science of time dilation it portrayed is very, very real. Which leads us perfectly to Section 4, Can we time travel?
Knowing that extreme speed and immense gravity can literally warp our reality and dictate how fast our clocks tick, we naturally have to ask the ultimate sci-fi question. Is time travel actually possible for humans? Well, the answer depends entirely on which direction you want to go. Traveling into the future is theoretically completely possible according to Einstein's physics. If you travel close to the speed of light or hang out near a massive gravitational force, you will absolutely skip ahead in Earth's timeline. However, traveling to the past, that is a totally different story. It's highly complicated and relies on unproven theoretical concepts like wormholes, cosmic strings, or rotating black holes. To date, no experiment has ever confirmed backward time travel. It remains one of science's greatest unsolved mysteries.
And that brings us to our final stop, Section 5, the universe's greatest mysteries.
Because despite everything we figured out about space-time, it turns out we are still completely in the dark about the vast majority of our reality. You might think everything we see, the stars, the planets, you, me, your computer screen, makes up the cosmos, but ordinary matter, the stuff we can actually interact with and see, accounts for a measly 5% of the universe. Just 5%. The remaining 95% consists of invisible forces, roughly 27% dark matter and 68% dark energy. We can't directly see either of them, yet they're entirely responsible for controlling how galaxies move, how they rotate, and how the entire universe expands. We are just a tiny drop in a totally invisible ocean.
And to put the scale of that ocean into perspective, it's almost impossible to comprehend. All of this ordinary matter, and dark energy is happening within an observable universe that is approximately 93 billion light years across. 93 billion. And honestly, that is just the part we can actually see because its light has had enough time to reach us. Beyond that boundary, scientists believe the universe might just continue on infinitely, perhaps even containing extra dimensions or parallel realities that we can't even begin to perceive. But hey, even just zooming into our own tiny local neighborhood of that vast expanse, the numbers are absolutely staggering. Take our own sun, for example. Every single second, the sun is furiously converting around 600 million tons of hydrogen into energy. That furious reaction is exactly what is currently bending the space-time around us, keeping our planet in a stable orbit, and providing the light and heat that makes the illusion of our everyday reality possible.
And if you think all of that is wild, I've got a few rapid-fire facts that will absolutely bake your noodle. Because of gravitational time dilation, your body actually ages slightly faster at the top of a mountain than it does down at sea level. Pretty crazy, right? Out in space, a collapsed neutron star is so incredibly dense that just one single teaspoon of its material would weigh billions of tons. Furthermore, not only is the universe expanding, but propelled by that mysterious dark energy we talked about, it is expanding faster and faster every single second. And finally, the ultimate mystery. We still have absolutely no idea what happened before the Big Bang. It just remains a totally blank page in the history of everything.
So, from the ticking clock on your wall to the furious expansion of distant galaxies, everything exists within this incredible, flexible fabric of space-time. Humanity has learned so much, but the greatest mysteries are clearly still out there, just waiting for the next Einstein to unlock them. As we wrap up this explainer, I want to leave you with a final provocative thought. Knowing what you know now about the bizarre rules of physics, if you could safely travel through time, would you choose to visit the past or risk a trip into the unknown future? And why? Think about it.